Hi everyone, Senan this side, and in this video we are going to solve this Geeks for Geeks daily problem, which is two smallests in every subarray. So you are given an array R. The task is to find and return the maximum sum of the smallest and second smallest element among all these possible subarrays of size greater than 1. It's a bit of a complex statement, so let's dissect this. And if it is not possible, then return -1. Okay, so first of all, we need to find smallest and second smallest in a subarray, in a possible subarray, right? And find their sum. Now, assuming I have found all subarrays and I have found all the minimum elements in that subarray, and I've taken the sum, and now I have to return the uh, maximum sum of that sum of these smallest and second smallest in that subarray. Okay, so when is it not possible? The only case when it is not possible is when you cannot find a smallest and a second smallest element. And when is that the case? That is the case when your array size is 1, or could be 0 as well. But if it's less than 2, you cannot find smallest and second smallest. So the idea is that for this, if the array size is less than 2, you return -1. That's for this state. Now you have to figure out the maximum sum of the smallest and second smallest element among all the possible subarrays. So what this question is asking, if you look at this test case, if you have this pair, right, the first subarray, so the smallest and second smallest is 3 and 4, so the sum is 7. For when you add another number, now this one is the smallest. Now the smallest is 1, second smallest is 3, so the sum is 4. So if we had to choose in between these two, we would choose the 7. Now in this case as well, it would be same as this one, because adding a 5 doesn't make any difference, and in this as well it doesn't make a difference adding a 6 because it's the largest element in this. But when you look at this, the smallest and the second smallest, this subarray, smallest is 1, second smallest is 3, sum is 4, and similarly you do this for all the three cases. Now in this case 1 5 1 5 6 and 5 6. Now if you see, for this subarray the sum is 11, and this is the maximum that you could get in all the possible subarrays. So what you return is 11. Now this is the case where you have to return -1, right? The array size is 1. Although you see this complicated expression, what you would think is find all the subarrays, then find the smallest and the second smallest, take their sum, and keep track of the maximum element, right? That is the thought process. But within these two lines, you'd get the idea of what we actually have to do. Now, assume we only have these two subarrays, and we had to choose the one with the maximum sum. Now we had 4 3, right? So we found that the sum is 7. But as soon as we added 1 to it, what happened is sum decreased, right? Why did the sum decrease? The sum decreased because we had a smaller element, either smaller than the second smallest or the smallest number. So whenever we found a number that is, or whenever we added a number which is smaller, our sum is getting lesser and lesser. But now let's observe at as these two cases. So if you see, we added 5 in this subarray. So what happened? The sum remained the same. Why did the sum remain same? The sum remained same because this is a number which is larger than the smallest and the second smallest in this subarray, or in this subarray. So there are only two things possible if you observe in this case and as well as in this case. What I want you guys to observe is that if you add an element into the subarray, either the sum would decrease or the sum would remain the same. So whenever you add another number in your subarray, it would never increase the value of sum, right? So whenever you add more numbers to the subarray, either the sum remains the same or it becomes lesser. But what we have to find is the maximum sum, right? So adding an element would actually decrease the value or keep the value as it is. Now, using these two conclusions, I could say that the smallest subarray I could find is of size 2, right? And adding a number would either decrease the size of the sum or keep the size of the sum same. It would never increase the value of the sum. So having a bigger subarray would actually decrease your sum or keep it at the same value. So in that case, that means that what we have to do is just figure out the pairs or the subarrays of size 2 and figure out the sum, and in the end return whatever is the maximum. So 4 and 3 is 7, 3 and 1 is 4, 1 and 5 is 6, and 5 and 6 is 11. So what is the maximum of that? That is 11, right? This 5 and 6, and so you return 11. So basically what you have to do is find the sum of all the pairs in this array and find the maximum of all the pairs, and that is the whole idea. That is how we are going to solve this. So if array size is less than 2, what you do is return -1, and now you define a maxi, which is the maximum sum, and initialize that to any number, let's say any small value. I say int min. Now what I do is for I is equal to 1 and array, I is less than array dot size. That means I'm trying to find all the pairs. How? I'm taking the array of I plus array of I minus 1, and I take the sum, and I update maxi with maxi, max of maxi or this value, and in the end I return this maxi. So that is the whole solution, and that is the idea behind this, right? What you had to understand is adding a number into the subarray would never increase your subarray sum, this constraint. It would never increase that. So what you have to do is find the sum of all the pairs, find the maximum of that, and return that. And if the size is less than 2, return -1. Okay, so we are done with this. Before I end this video, I want you guys to know that you can find the whole solution PDF in the description below with my code, intuition, and approach with time and space complexity. So the time complexity is big of n for this for loop, and space complexity is big O of 1, because we are just having a single maximum element. We are not considering the space taken by this array. So yep, that is the video. Thanks for watching, and I'll see you in the next one.